Let's learn how to calculate the sample proportion, denoted by p hat. The sample proportion is the proportion of individuals in the sample with the characteristic of interest. We calculate it using the formula p hat equals x over n, where x is the number of successes and n is the sample size. Remember, a success simply means the outcome we are counting. It doesn't mean something good happened. The value of p hat is always between 0 and 1. If you prefer, you can also express it as a percentage by multiplying by 100%. Let's try example 1. A poll of 200 voters finds that 77 support candidate Brown. First, identifying the number of successes. Since we are counting the voters who support the candidate, so X is the number of people who support the candidate, which is 77. And the sample size is 200, so N is 200. Question A, find p hat. We use the formula p hat equals x over n. X is 77 and n is 200, so we'll have 77 over 200. And that equals 0.385. So the sample proportion is 0.385 or 38.5%. Now, let's interpret this result. A sample proportion of 0.385 means that 38.5% of the voters in this sample support candidate Brown. Notice that we are describing the sample, not necessarily mean the entire population. Now that we know how to calculate the sample proportion, the next question is, can we model a sampling distribution using a normal distribution? The answer depends on two conditions. We can use the normal distribution if both of these conditions are satisfied. First, n times p is greater than or equal to 10. Second, n times 1 minus p is also greater than or equal to 10. These conditions ensure that we expect enough successes and enough failures for the normal approximation to work well. A common mistake is checking only one condition. Always check both before using a normal distribution. Let's look at example 2. Suppose the population proportion is 0.35 and the sample size is 155. Let's calculate n times p. 155 times 0.35, which is 54.25. Since 54.25 is greater than 10, so the first condition is satisfied. Now, let's calculate the second condition. N times 1 minus p. So we have 155 times 1 minus 0.35. 1 minus 0.35 is 0.65. So we have 155 times 0.65, which is 100.75. Since 100.75 is greater than 10, so the second condition is also satisfied. Because both conditions are met, we can use a normal distribution to approximate the sampling distribution of the sample proportion.